Okay, let's give you guys some practice. So work out the purple area. So work out this purple area here. Work out this purple area here. And the equation for the blue curve is given by this. So that's this line here. And the equation for the red curve is given by this. So it's doing this. So work out the blue, work out the purple area. Press pause and have a go. Okay, so to do this, we are just going to concentrate on a quarter of the whole thing. So our aim is to work out the area of this whole thing here, and then take away the area of one petal. That will then give us this area here, a quarter of our intended area. So so if we want the whole purple area, we would need to times it by 4. So 1, 2, 3, 4. That will then give us the whole thing. But our first task is to work out this area. And in the previous video, not the previous, in one of the early videos, we've worked out the area of one petal. And the area of one petal is given by this. So the area of one petal is us integrating it from 0 to pi over 2. And I've already done an explanation as to why it's pi over 2. So it's in one of the early videos. And if you want to integrate sine squared, you've got to think about this. And it's blah, 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 blah. The area of one petal is given by pi over 8. I've already done a video on this in one of the early videos. So now we know the area of one petal. We know the area of one petal. We would need to know this area here. We would need to integrate it. We would need to work out this whole thing now. We would need to work out this whole thing here. So when the angle is 0, then this thing here would be 1. So you know the radius is 3. So that's why the radius is 3 when the angle is 0. So when the so it's moving around like this, we need to work out at what angle will the radius be 1. Because by looking at this, for all we know, this could have done 3 revolutions, well, we need to work out at what angle will the radius be 1. We need to work out when the radius will be 1. So so set this thing here to 1, and then the angle which the radius will be 1 will be pi over 2. So we need to integrate it from 0 to pi over 2. I know it's kind of obvious looking at the diagram, but for all we know, the particle could have zoomed really fast across here. So you got to make sure, you got to work out what angle will make the radius 1. For all we know, it could have gone backwards for all we know. But anyway, so it turns out that we need to integrate it from 0 to pi over 2. So a quarter, we're going to call this area here a quarter. I'm going to assign this area here. Hang on, I'm going to assign this area here. I'm going to assign this area here and I call it the name quarter. So this name here, quarter, this name quarter is given by this. So now multiply this thing out. That will then give you this whole thing here. And whenever you want to integrate cos squared, think about this. And remember, this angle here is always twice the size of this angle here. So it's always twice the size. So it's always twice the size. So that will then take us to here. And then now break this up. So it's one block, add another block. And then let me think. And then merge these two together. That will then give us this. And then now integrate. So integrate with respect to theta would be this thing here. Integrate this, it will then be this. Integrate this, it will then be this. Now we've got to put this into here. That will then give us this. Put this into here. That will then give us this. Put this into here. That will then give us this. And then take away. Put this into here, which would be 0. Put 0 into here, which would be 0. Put 0 into here, this would be 0. So it turns out to be this. Sine pi is right here. That's 0. Sine 2 pi, this thing here will be 0. So so our area is given by this thing here. So wait there. Let me just rephrase. This quarter thing here is this whole area here. Is this whole area here? And then we need to take get that and take it away. Get this. Take away the area of the petal. So the petal is given by this. So a quarter of our intended area, is given to us by this thing here. Take away the area of one petal. Take away the area of one petal. That will then give us a quarter of our intended area. Okay, so times it by 4, and then our whole area is given by 4 pi. So this whole purple area here is 4 pi. Okay.